Okay, so for this question, we need to first find the inverse and then to verify. So once we found the inverse, verifying would be easy, right? We just need to substitute into the inverse function to get g to g inverse 4, and then substitute that number into the original g function gx to see if it is 4, because we're verifying it, we're not proving the property of the inverse function here. So then how do we really find the inverse for gx, right? It looks pretty complicated here. There's square root involved and we couldn't really get clear of it. But if you notice that x versus square root of x is somewhat like x squared versus x, right? They're actually a square function, a square relationship, right? If I square the right hand side, square root of x, I actually do get x. So gx in some way is almost like a quadratic with square root x as the variable, right? If I can, I may write it like square root of x minus a squared minus 6x square root of x plus 1, then I can complete square in that way, right? I'm just gonna make everything slightly clearer here, and right. Okay, so square root of x squared minus 6 square root of x, then I am adding a 3 squared minus 3 squared plus 1, right? So essentially I got square root of x minus 3 squared minus 8. Okay, now we can put a y here now, because using y helps us better to visualize how our inverse is going to look like. Now, essentially the next step would be y plus 8 equals to square root of x minus 3 squared. And then next step, I will have to take square root on both sides, right? So when I do that, I have a issue, which is I don't know if it's positive or negative here, right? So if I can't see it now, I'll just keep it and see if more information will surface as I keep going down, okay? I'm gonna write here. So the next step would be 3 minus plus or minus square root of y plus 8 equals to square root of x. Now, here, the domain of x becomes quite helpful here, because x is between 9 and 0, so square root of x would definitely be between 3 and 0, right? Okay, so this number needs to be between 3 and 0. So, which means that 3 cannot be bigger than 3. So 3 cannot be added to another positive number, because the square root of y plus 8 will definitely be a positive number, right? Since the largest number square root of x can attain is 3, we know that we should take, change the color, we should take this one here. Make it to 3 minus y plus 8 squared will then equals to x, which if we change the variables here, right, that's our inverse function. Okay, so the next step that we get into is basically looking for the inverse of g4 would equal to 3 minus 2 root 3 squared, and then put that number into the gx here. We'll realize that g composite with g negative 4. Notice that this notation is the same as this notation, okay? Right, and then it naturally becomes 3 minus 2 root 3 squared minus 6 times square root of x, which is nice because here this is our x now. So square root of this is 6 times 3 minus 2 root 3. Let me see if I can, oops, that's the end. Root 3, and then plus 1 at the end. Okay, here, yeah. Okay, through bunch of calculations. I'll do it briefly here. We will have a take away 12 square root 3. Here it's a multiplication, it's not a x here. Okay, so minus 18 plus 12 square root 3 plus 1. I realize actually, our square root 3s that we really worry about will disappear, and then we have a 22 minus 18, which does equal to 4, so we verify that.